Hi, today I have this little board. This board is actually the air data computer of the Shahed 136 drone. I have a picture which shows the complete device. We have on that side two pressure sensors. One is an absolute pressure sensor, which is for the static pressure, so this permits the measurement of the altitude. The second one is a differential pressure sensor. It permits the measurement of the difference between the pitot pressure, which is on that tube, and the static pressure, which is also fed to that tube here. These two inlets are connected together. There is here a small DC-DC converter, a sub-D9 connector here. We have here an AD3232, which permits the interface with an RS232 bus. Here there is a TO92 part, which is the classic TL431. On the other side, we have here a microcontroller, which is an STM32. There are some passive parts, a few diodes here. Here there is an SOT223 part. It is probably a regulator. So this is a JTAG interface for the programming of the microcontroller. Okay, so I think I will do the reverse engineering of this board. It is not complicated. I will find the input here for the power supply. It should be these two lines here. Okay, so I will find the pinout of this connector, and I will see if there is something at the output here. We can see that some data are transmitted, approximately 5 messages per second. The duration of one complete message is approximately 60 milliseconds. One bit corresponds to approximately 50 microseconds. The baud rate should be 19.2 kilobaud. We can see on the screen the complete schematics of this air data computer. The two sensors are here. They are connected to the microcontroller using an SPI bus. There are also two lines which permit the selection of the sensor. The power supply is here. There is this DC-DC converter which generates a voltage of 5 volts and a linear regulator which gives a voltage of 3.3 volts here. And there is also a voltage reference, this part, which gives probably a voltage of 2.5 volts here. So here we have an interesting circuit. This is a classic current source built around the TL431 here. Okay, so there is a sink current on that line. This line is connected to one pin of the microcontroller. I think it is an analog input. So we can see also there is a capacitor, and these two lines are also connected to the sub-D9 connector. Probably between these two lines we have the temperature probe. So this permits the measurement of the external temperature. For the test, I have connected this vacuum pump to the static input pressure of these two sensors. Okay, so they are connected in parallel, and also the pressure can be monitored using this vacuum indicator. I have also connected the output of the UART to this computer using a monitor. Okay, so let's start the measurement. We can see that we have 3 different messages. All messages start with this string here, PTAHAD, and at the end there are 3 different letters, A, C, and V, okay, for various parameters. For the first test, I will apply a pressure only on the static pressure sensor. I will apply a pressure of minus 200 millibars. This corresponds to an altitude of 6,000 meters approximately. Okay, so we can see something interesting. You can see that we have a value here of 6,200 approximately. So this corresponds to the altitude. I will do the same measurement, but with applying also the static pressure on the pitot-static sensor. Okay, so the pressure is 200 millibars on both sensors. Okay, we can see that we still have 6,200 meters here, but here we have another value, 259. This value corresponds to the airspeed of the drone. So we can see that there is another value here, 281, so this should be another airspeed. This is the result for a pressure of 50 millibars. Okay, so we can see an altitude of 1,550 meters. And we have here the true airspeed, and this is the Mach number, this one here, 0.275. I don't know the signification of this value here, 23.1. This value changes a little bit with the pressure, and there is another value here, which is more or less constant. There is also this value here, 0.07. I didn't find the meaning of this value.